With the exponential accumulation of technical text data from the unprecedented advances in data-driven techniques, it has become a critical task to create high-quality data annotations from unstructured technical text. To solve this problem, we develop LabelVizier, a human-in-the-loop workflow to facilitate efficient validation and relabeling of technical text annotations. The workflow consists of three phases: error profiling, annotation validation, and annotation relabeling. The error profiling phase involves data processing and a surrogate model training process utilizing the technical text along with annotations of unknown quality. Then, in the following two phases, users can interact with a visual analytic interface with multiple views to achieve efficient annotation validation and relabeling. The interface of LabelVizier includes three main components: a label investigation view to visualize labels and their hierarchical and co-occurring relationship, a record distribution view to present the distribution of technical records on the model's confidence vector or the input's word vector, and an operation panel for supplementary information and control support. We present our VA interface along with data processing and model training process in an interactive notebook to support more flexible user customization. In the following use case, we show how LabelVizier can be used to improve the annotation quality and help make reasonable maintenance plans with an HVAC dataset from a collaborative institute. It contains machine maintenance logs for the heating, ventilation, and air conditioning systems of the institute with 8 categories of labels. After loading the dataset into LabelVizier, we execute all code cells to pre-process the data and train the machine learning model, and then compile the visual interface embedded in the notebook. First of all, we start from screening the duplicate labels from the label investigation view. We notice that the category PI has the brightest color, meaning that it is the most likely to contain duplicate labels. Therefore, we expand this category to investigate all corresponding labels more closely. We find that the core connections between labels office too hot, room too hot, temperature too hot building, and too hot room are relatively thick, which means they co-occur highly frequently with each other. We click on each of them and update the Inspect tab on the operation panel to show the data details and confirm that all of those annotations are duplicate labels. We reflected this discovery to the domain experts, and they told us that this label duplication issue would cause inaccurate statistics of the too hot issues and result in the unreasonable assignment of maintenance priorities. To correct this error, we suggest modifying all the duplicates to the same label, room too hot, under the Relabel tab. Now let's switch to the record distribution view to search for wrong labels. In this view, each dot represents one record in the dataset, and their color encodes how confident the model is to annotate this record. LabelVizier also supports different coloring and projection combinations to provide various perspectives in the label investigation view. With the current selection, we can see several clusters with low confidence scores, so we use the lasso tool to select one of them for further analysis. From the Inspect tab, we find the label BR Richard in category X appears in every record within the selected cluster. Since BR Richard is not semantically meaningful, it is likely to be the wrong label. To confirm our hypothesis, we move to the Categorize tab and click on one cell under the category X, indicating relatively lower prediction confidence. From the triggered Lime explanation for the model behavior, we find BR Richard is the top prediction, but the positive contributors to the prediction are relevant HTML metadata. By checking other cells in category X, we confirm that BR Richard is the wrong label, semantically associated with uncleaned HTML metadata. From the Inspection tab, we find more HTML correlated labels that appear very frequently in this cluster, including the label Richard in the I category, and the labels BR Division and Text in the U category. Therefore, we decide to remove them from records in the selected cluster and conduct a thorough HTML metadata cleaning for the dataset. Finally, we apply our modification suggestions to the dataset, and the system re-rendered automatically to visualize the updated labels. We can see that the labels are cleaner now because of our relabeling operations. For details, please refer to our paper.